So, friends, as told in the introductory video, after the work at home orders by the government with a special cause, I was giving out videos in the regional language for the state of Gujarat and the students here. But as I told you, that being a part of a UGC affiliated, or rather to say, a college that has been funded by UGC and the state government, I'll give few of the videos, or rather to say the topics that can be streamed all over the country or the globe in this universal language. Already the first video of chromatography part 1 is out. It is in the regional language. So we are coming up with chromatography this time. But when we discuss chromatography, we'll be dealing with three things today. One of which will be the basics, the definition, and the terms involved. Not much, but a little bit of column chromatography and most of its explanation, followed by the thin layer chromatography and paper chromatography. A very explanatory note was given in the first talk of chromatography regarding the classification of chromatography. I'll repeat the same because now it's in the global language. So, friends, whenever we talk of chromatography, let us first make it very clear that it's a separation technique. It's a physical phenomena that helps us in separating compounds prior to analysis. If I have a mixture of A plus B plus C in the form of a mixture, and if someone wants to claim A to be benzene, B to be toluene, and C to be cyclohexane, looking to the mixture directly, I'm not sure whether he would be able to tell that it is benzene, it is toluene, or it is cyclohexane. But if a phenomena of a separation is undertaken at some instance or other, the particular person involved would be able to separate mixture A, B, and C. And once separated, he would be able to reach to a conclusion that A would be this, B would be this, and C would be this. That is respectively in this example benzene, toluene, and cyclohexane. But if you think that chromatography or any technique directly related to chromatography itself is enough to do so, we are wrong. It is not a technique to identify, it is a technique to separate. Remember very well. It is a separation technique. And if you look on the screen to the definition given, chromatography is an analytical method used to separate compounds physically prior to measurement. And yeah, afterwards, if you say it is mass spectra or you say it is NMR, LCMS or LCNMR nowadays, then this LC, that is liquid chromatogram, is something that is used for separation. And this profoundly can be used for identification. So it is a separation technique. As told in chromatography, we'll just first look to this beautiful experiment on the board. If we go back to the history of chromatography and we look into what happened, a Russian botanist, Mikhail Svet, did a very beautiful example by taking a column. Now the question comes, what's a column? We all in our laboratories, at our colleges or schools, or rather in our master degree programs, have seen a burette, but there are still very few laboratories where we get columns very easily. But a bigger version of a burette, at least 5 to 7 times in width and twice in length, is enough to describe a column made up of a glass having a pinch cork or a glass cork at the bottom as it is visible in the picture. What this honorable scientist did, he just took some leaves, crushed them down, and after crushing them, he took a beaker full of ether and added the crushed leaves to it. He just kept on stirring it so he could get some part of the leaf extracted in ether. And it is very easy to identify whether some or other part is extracted or not, because the solvent ether was colorless. But when the leaves were crushed in, mixed very well, stirred rather to say, its color changed to green. Means there is something that has happened inside ether. And that phenomena basically a chemist or a botanist explains to be extraction. This extracted solvent was then poured through the top of this column. If it was just made up of a single component, which generally from our school days is popularly made known to us as chlorophyll, it would have shown a green patch. But to your utter surprise, there were more than one patch coming inside. It means there were more than one component present. See, you cannot directly add this liquid, or rather to say the extraction inside the column. You have to fill that column with some solid material, and that solid material for him was calcium carbonate. So when this column was filled with calcium carbonate and he added from the top the extracted solution now of ether plus leaf extracts, he could find inside that column different color patches, which clearly indicated that the solution had more than one component extracted. So he could come to a conclusion that if I have something solid filled in a pipe, now a column, and if I pass the mixture from the top, I could separate them. Henceforth, slowly and steadily, he could coin the word chromatography from the word colors, graph, chromography, graph of different colors that could result out from this technique. So this was how chromatography came into existence through a very simple experiment by a Russian botanist, Mikhail, Mikhail Sven. Moving further, as now we are entering into this world of chromatography, we should be aware of few important terms that are related to it. If you see these four terms, stationary phase, mobile phase, chromatogram, and the retention time, they play a very crucial or a vital role in the technique chromatography. When you have a cylindrical column and it is filled with some or other solid material, it is stable, it does not move, and henceforth we coin it as stationary phase. Now, if you remember the previous slide, it was this petroleum ether coming from top, moving out from bottom, and helping to separate the components from a matrices. So this movable part that keeps on moving and does not remain stable is called mobile phase. So if we take the first example, for us, Calcium carbonate is the stationary phase, and ether is the mobile phase. Let us keep this third term, chromatogram, out of the picture as of now. And this fourth term, retention time, let us coin it as time taken by one component to reach from one end of the column to another end of the column is called retention time. For example, if we go back, there are three patches. Let us assume that the green patch is backward. It means it will take a larger time. And if you do not understand this statement as of now, do not worry, it will come later on. But the time taken by the green patch, red patch, and the black patch, or rather say these components, from the top end to the bottom end of the column, it is called retention time. So over here, those patches are represented by these circles of different colors. If you see the top of the column, you have two component mixed, but as it travels to the bottom of the column, they get separated. It means there is some mechanism of separation taking place. This mechanism is called chromatography. Now, a little bit more in detail, this technique where you are using a glass column, you are separating the compounds, let us call it to be column chromatography. The three columns that are visible on the screen are not different, they are one. But the column has been photographed at different time fraction. So if you see the column number 1, where you can see the orange color patch, it is a mixture of two components, but with the passage of time, both the components get separated a little. And with the more passage of time and the constant flow of the mobile phase, that can be ether, is one of the experiment has told us, the components are separating. So this is how chromatography, if operated through an application called column chromatography, can be explained as one of the separation technique. Now, once we have this, we should first of all be aware of the classification of chromatography. We came across two terms, that is mobile phase and stationary phase. And if I try to classify them on the basis of these two terms, and I intentionally start classifying them using stationary phase as my base, generally we have seen solid as a stationary phase. But you would be surprised to know that you have another medium or a phase or a state of a matter that can be a solid surface. And that is, in simple words, liquid coated on solid. So as of now, the concept of being stationary among solid, liquid and gas was restricted to solid only. But now that has been extrapolated to a liquid which can be coated on solid. So we have two stationary phases, stable phases that do not move, and they include solid as well as the liquid coated on a solid. Now, once you have a solid surface as a stationary phase, you can either take liquid or gas as your mobile phase. The mobile part, the moving part, can be liquid, can be gas. Imagine this cylinder filled with a solid. You can pass a liquid as a mobile phase. You can even pass a gas as a mobile phase. Interesting. Similarly, If I make liquid coated on solid as a stationary phase, again it would be interesting that I can pass a liquid as a mobile phase, or I can pass a gas as a mobile phase. So in all, while classifying the chromatography, I get four combinations. If I have a solid as a stationary phase and liquid as a mobile phase, I would always remember it as column chromatography. We'll come to something else very soon. If I have a solid as a stationary phase and gas as a mobile phase, I will come to gas solid chromatography. Going to the opposite side, if I say that liquid coated on solid is my stationary phase and another liquid is my mobile phase. That's a liquid-liquid combination. Very rare, a little clumsy to understand, but we can understand it by using different reference book very easily along with an experimental approach. I'll get paper chromatography and thin layer chromatography with asterisks, that is condition applied over to this classification. And if I have a gas as a mobile phase and a liquid coated on solid, rather to say a liquid as a stationary phase, I can come out with gas liquid chromatography. So, four different combinations on the basis of stationary phase and mobile phase, resulting into several different techniques, all chromatography. You have column chromatography, you have gas solid chromatography, you have paper chromatography, you have TLC, you have GLC. I have seen people sometimes keeping these techniques over here. You can keep them for a while in this combination of liquid solid chromatography, but when you go through the mechanism they follow, you cannot. For example, when you say that you have a solid stationary phase, it always undergoes a phenomena of adsorption for this separation. And there, this fails a bit. When you say I have a liquid coated on a solid, or rather say a liquid as my stationary phase, then always remember partition is the phenomena or the mechanism through which separation will occur. So, you should first try to learn from the external sources available with you the phenomena of adsorption that occurs on a solid surface and the phenomena of partition that occurs on a liquid surface. And then it will become easier for you to digest paper and DLC as a part of a liquid-liquid chromatography. And when I was speaking for a liquid-solid chromatography column, and I stopped saying that I'll add something else, that was there are some drawbacks of column chromatography. Separation inefficiency, time consumption is more, and wastage of solvent, which demanded for a new technique. And that new technique are HPLC and UPLC. And friends, HPLC and UPLC with specific reasons can be placed in this category of solid liquid combination using the mechanism phenomena of adsorption separation and not the partition separation. So this is how you can classify chromatography on the major basis of stationary phase and the support basis of mobile phase, resulting into four different combinations and 7 to 8 different techniques. Now, this was all about the basics of chromatography. About the basics of chromatography, we just saw a very precise explanation on the classification of chromatography. As you all know, HPLC was already made a few years before in the regional language. So I'll try to explain the same at the later stages of these recordings in the universal language. But once we are versed or clear with what chromatography is, what are the major components, like the stationary phase and the mobile phase, like the retention time, what can be the classification of chromatography, how this column came into existence, what was the history of chromatography, we should now move towards the first two popular techniques that can be used both in the laboratory as well as the research is at BSc, BS level, MSc, MS level, or even at the level of research. And these techniques includes thin layer chromatography and paper chromatography. As of now, in the classification, in the current video, we have placed them in the partition phenomena and not in the adsorption phenomena. So friends, this first recording of our comprised of chromatography, its basics, about the basics when we move. It also included the classification of chromatography and the important terms related to chromatography. Now, we'll keep on continuing with the recording, but I'm going to divide it into two videos so it becomes easy for me to upload. So this brings an end to the first part of chromatography in the universal language. And now, very soon, after stopping this video, I'll again start recording this above stated topic, that is paper chromatography and thin layer chromatography. Remember, as of now, you have a few minutes with you. Just Google on or find out what do we mean by the phenomena adsorption and what do we mean by the phenomena partition. As of now, I wish to keep them in partition with an open end that we can bring them to adsorption at any instance of time with a perfect reason in science. Thank you.